Okay, here's part two, geometry students, for our final exam review. We're going to be looking at the famous SOHCAHTOA, and let's take a look at these 17 through 18D. It says, for the righteous triangle shown, write the specified trigonometric ratio. Don't be rattled by this term. Trigonometric ratio is just either the sine ratio, the cosine ratio, or the tan ratio. Write it as a fraction and also as a decimal, where possible round your answer to 4 decimal places. So the thing you want to keep in mind is SOHCAHTOA. Go ahead and say that to remind yourself. SOHCAHTOA. And here we have the sine, which means opposite over hypotenuse. The cosine, which means adjacent over hypotenuse. And finally the TOA, where tan is opposite over adjacent. So just keep that in mind. And also keep this in mind that the sine, the cosine, and the tan is always going to be of an angle. And the opposite, hypotenuse or adjacent, will be a length, a side length. Okay, again, the sine, the cosine, and the tan will be of an angle. And the opposite, hypotenuse or adjacent, those are lengths that we're looking for, or side lengths. So let's go ahead and take a look here. First thing we should find here is AB, because we're missing this side length here, AB, and it's a right triangle, so that should be easy for you to do. AB, let's call it C. And since it's the hypotenuse, we can find it by saying C squared is equal to A squared plus B squared. We're finding length AB. This is just a Pythagorean formula. 20 squared, and use your calculator here, it's going to be 400. And 21 squared, if I remember right, that would be 441. So that's going to be C squared, or AB squared. Looking for AB. This is, when we add it, we get 841. That's C squared. So AB, which is the same as C, will be the square root of 841. I think that's 29. Let me double check it with my calculator here. 841. Yeah, that's going to be 29. So that gives us the third side length. And once we have the three side lengths, which we have now, we have 20, 21, and 29. We can find either the tan, the sine, or the cosine very, very easily. Let's go ahead and do a few of these. The tan of angle B. So it's this angle here. It's going to give you the single arc. Tan of angle B, and that's the TOA. Tan is going to be opposite length over adjacent length. So we go opposite to angle B, which is 21, over adjacent to angle B. Adjacent means neighboring. It's this one. It's not this one here, and I hope you know why, because this is the hypotenuse. It's going to be over 20. So that's the simplicity of it, 21 over 20. And if you divide 21 by 20, we're just going to do it right now. 21 divided by 20, I get 1.05. 1.05. And if you want to go to 4 places, then you can just do 0, 0. I'd like you to do this in your calculator just to see that you're getting the same thing. 21 divided by 20. All right. How about, let's do this one here, since this has to do with angle B as well. How about the cosine of angle B? Still angle B, so cosine, what is that? Ca is adjacent over hypotenuse. So adjacent length to angle B would be 20. Write that down. And the hypotenuse is going to be 29 without question. So that would be my cosine ratio. Ratio is just one number over another as a fraction. And when we do 20 divided by 29, I'm doing it right now. You should do it as well in your calculator. Divided by 29, I got 0.6897. 0.6897. 0.68, should be a 6 before that, 97. So that would be the extent of angle B. Let's move over to angle A now. Angle A is this angle right here. I'm going to give this a double arc, so the spotlight should be right on this angle here. And we're looking for the sine of angle A. And the sine, what's the sine? The sine is the opposite length over the length of the hypotenuse. So here we come to angle A, and opposite to angle A would be 20. And the hypotenuse, without a question, is going to be 29. It seems like we've seen that before. Here it is, right here, the same thing. So this is going to be equal to 0.6897. And I trust by now you can do the tan of angle A. It's a tan of angle A, this same angle here, so the spotlight shines right here. Okay, tan of angle A, and tan is what? Opposite length over adjacent length. So opposite to A is 20 over adjacent is 21. So here we go, 20 divided by 21, that gives 0.9524. 0.9524. Okay, make sure you know these. You're going to have a number of questions on these, maybe about 5 questions related to this. So if you need to, just go back and play it again and take a look and make sure you've mastered this. This is going to help you as you go on to trigonometry. Some of you might do trigonometry honors, some of you might do pre-calculus, and some of you calculus as well. So it's going to help you. All right, let's take a look at some of the application now of the sine, cosine, and tan. All right, use one of the trigonometric ratios to find the value of x necessary around your answer to the 10th place. The 10th, I trust you know what that is. So let's go ahead and look at this one. Take a look at this. We have an angle, 33, and we're looking for x. So the question is which one to use. Should we use the sine ratio? Should we use the ka? Or should we use the toa? Okay. The one we use will be the one in which we know 2 of the 3 features. So let's just go ahead and take a look. Spotlight is on 33. So let's say you say, okay, should we use the tan? Let's try. If I say tan of 33, that's the toa. That's going to be opposite over adjacent. Here it's going to be opposite, which is x, and we do want the x over adjacent. Adjacent, we don't know this. So we don't know the x, we don't know the adjacent, so we can't use this. But not to worry, let's try another one. How about sine? Because we know sine has opposite involved. So let's try sine. Sine is opposite over hypotenuse. So let's try that. Sine, it's going to be of the angle again. Angle 33 is equal to the opposite length, which is x, over the hypotenuse, which is 17. Take a look. We know this and we know this. Okay, so once we know 2 out of the 3, we're home free. We can use it. Let's go ahead and cross multiply. We have x times 1 is x. The answer is going to be 17 times sine 33. Okay, let's go and do that right now in our calculator. I'm going to do 17 first, and then times sine 33 equal, I got 9.3 for this one. 9.3, and the 10th place is just one number after the decimal right here. Okay, how about if you do that one, this one right here? Maybe I'll help you to set this one up, but here again going to be either the sine, cosine, or the tan of the angle. And we want to relate the x and the 15 to that tan, cosine, or sine. So what do you think? I see this length here is adjacent to the angles. So I'm thinking that maybe cosine or tan would work. I'm leaning towards cosine because if I say cosine, cosine is adjacent over hypotenuse. Adjacent is what I want, and the hypotenuse I know. So the setup would be cosine of 31 is equal to adjacent, which is x, over hypotenuse, which is 15. I know 1, 2 of the 3 features, so I can work it out. Okay, so x times 1 is x. Your answer is going to be 15 times the cosine of 31. Okay. So you go ahead and finish that up. Um, let's take a look at this one. You might recognize these. These were in the test, and I think we have time to finish these up. These were the bone eyes here, and I said find. But let's do this one first, since it comes in sequence to what we've been doing. Number 22. It says find how high the ladder is above the ground. So this is what we want to find. This length here, I'm going to call this x right here. Okay, we have this ladder, 15 feet, and it's above the ground by that much. So we look at this angle and we say, oh, this angle is 25. So should we use SOHCAHTOA or TOA? The x is opposite to the angle, so it seems like we need something opposite, and we have the hypotenuse. So opposite, hypotenuse, what would that be? That would be the sine, wouldn't it? So it's a sine of 25 would be the opposite, which is x, over the hypotenuse, which is 15. Here again, we simply cross multiply. X times 1 is x, and this time this gives me 15 sine 25. If I work this out, I do 15 and then sine 25 in my calculator. 15 times sine 25 equal, that gives me 6.3 for the answer, and that's rounded to the 10th place. So that would take care of those types. This one here, I have a mistake on this. I actually should have put a 30 degrees here. Tell you what, this is a 30, 60, 90. And in the 30, 60, 90 triangle, the length of the hypotenuse, you might remember, is twice the length of the shorter leg. So this is 10 root 3, and the shorter leg must have been half of that, which is 5 root 3. The length of the longer leg is going to be the square root of 3 times the length of the shorter leg. So this would be 5 root 3 times root 3. Root 3 times root 3 is root 3 squared, so this would be root 3 squared, which would be 3. So the answer here would be 15. Alright? So that should help you. Do your best, and I look forward to seeing you soon. Bye-bye.